My name is Kathleen Thick, and today I'm going to be giving a lesson designed for 7th grade integrated science, and we are going to be talking about temperature and heat. Given that we're going to be talking about temperature and heat, let's take a moment to think about our surroundings and how we feel right now. Are you sitting by a sunny window? Do you feel warm? Maybe you're by a vent that's making you feel cool. Temperature is everywhere, and I thought it would be fun to measure the temperature of a few different items in this room. One interesting thing about temperature is that temperature has a tendency to equalize over a given period of time. So if you don't have a heat source or a cooling source, and you're in a controlled environment without a window that has sunshine, you're going to find that all of the items in the room will be about the same temperature. Now in this case, I do have a window, and the sun has been streaming in onto this side of the room. There is no visible vent, and I have not been running the fan. All the items in this room have been sitting here for a very long time. So we should be able to guess that the temperature of most items in this room, regardless of what they are, if there is no heat source and no cooling source, we're going to see that things are just about the same temperature. Let's start with my bookcase right here. It is a little warm in here. Bookcase is coming in at 77.8. So you can see how this works. Surprised it's that warm, but I do feel a little warm. Okay, I'm getting 78 on that wall. Let's try the handles on the bookcase. 78.0. So all these things are within 1 degree. What's funny about measuring the, let me show you what I did. Measuring the handles on the bookcase and then being 77.8 is that they feel cooler. They actually feel cooler than the rest of the bookcase. I wonder if it's the same with the door. The door I'm getting 78.7, and the doorknob 78.5. But it's funny because the doorknob feels quite a bit cooler. Today we're going to be doing a demonstration of how temperature changes and how temperature tends to equalize over time. I have brought with me some items from home. These are safe items to retrieve. This is a safe project to do. We always want to be safe in our science classrooms, and so I thought hard about it, and I think you'd have a really hard time hurting yourself doing this project. So we have our cutting board, and we have a frying pan, and I just brought in these ice cubes from the freezer. And one interesting thing about the ice cubes is that they are a source of cool. They are measuring in at 36.1 degrees. So there's one thing in this room that has not achieved equilibrium today. So what I'm going to do is place a few of my ice cubes onto the cutting board and a few of my ice cubes into the frying pan. What do you think will happen? Do you think that those ice cubes will melt at the same time? Do you think that they will melt faster on the cutting board? Do you think maybe that they'll melt faster in a frying pan? Well, I would think that they would melt fast in a frying pan because I think a frying pan like cooking. But I'm not going to put this frying pan on any heat. And it actually feels very, very cool to the touch. I guess you want me to measure the temperature of these items, and I'll do that. Temperature of the frying pan, 78.9, and the temperature of the cutting board, 77.9. So, again, they're about the same temperature as everything else in the room. I think the frying pan might have been a bit hotter because I was handling it. So, what do you think will happen when I put those ice cubes on? I want you to form your hypothesis of whether they will melt faster on one of these two surfaces or whether they'll melt at the same time because they're ice cubes and ice cubes are ice cubes. They're going to melt the same. So be thinking about that, and with no further ado, I'm going to try to put about an equal number of ice cubes, 1, 2, 3 ice cubes onto my cutting board, and 1, 2, 3 ice cubes onto my frying pan, and let's see what happens. Here are the ice cubes that we put onto the cutting board. They are just hanging out. Yes, ladies and gentlemen, we are watching ice melt. Well, it seems to be melting pretty slowly, given that this room is pretty warm. And let's see how our ice cubes are doing inside the frying pan. Oh, my goodness. Well, here's something to behold. These ice cubes have wet the entire surface of the frying pan with their melty, melty water. And there's an actual pool of water. The ice has melted so much that we're looking at ice soup. Who knew? Well, we did look at the cutting board first, so let's see if maybe those ice cubes on the cutting board have caught up to the ice cubes that we have here in the frying pan. What do you think? Well, it's kind of hard to see because I chose white, but they aren't even breaking a sweat. Well, maybe they're breaking a sweat. They're glistening a little bit. But if you don't believe me, I can tell you there's no real water droplets. There's no ice soup. They're holding strong. And meanwhile, the frying pan, my goodness, there's hardly any ice left to speak of. There's still some ice there. They haven't melted entirely. And I know, I told you that I wasn't going to use a heat source, and this was going to be such a safe experiment because I'm not using any heat source, but I can think of a heat source that's at my ready disposal to put on this frying pan. It's me. I'm 98.6. So let's try heating these up and see what we can see. There's not much ice left. Look at that bottom ice cube there. It is nearly gone, ceasing to exist. Just from the heat of my hand, I've turned those ice cubes almost entirely to water. There's still a little bit left. Oh, let's try heating them up on the cutting board. Okay. They're still holding pretty strong. I don't see any droplets yet. But let's try putting my hand underneath. Unfortunately, I don't notice any reaction. There's no real water. They're not sliding around. Maybe a little bit. They're starting to melt a little bit. But I didn't notice any big change when I put my hand under there. Have you ever heard of these words? Conductor and insulator. Which of these two items, the frying pan or the cutting board, do you think would be considered a conductor? Which of these two items do you think would be considered an insulator? Did you guess that the cutting board was an insulator? Because if you did, you would be correct. Our cutting board is made of plastic, which is an insulating material. It does not quickly conduct the heat around it. It allows your ice cubes to stay chill. It's not in a big hurry to equalize that temperature. Eventually, of course, they will melt, but the cutting board isn't doing anything at all to advance that process. On the other hand, we also have our frying pan. Our frying pan is a conductor. You must have figured that out from the process of elimination. It's a conductor. And yes, when I touch it, it feels cold. Feels cold. But what's really happening is that the frying pan is conducting the heat away from my hand, away from my body, because my body is a source of heat. I'm warmer than the rest of the room. So, even though I feel cold, that feeling of coldness is not going to keep our ice cubes from melting. In fact, I told you that there was no heat source, but even before I touched the pan, there was definitely a heat source. That heat source was the 77-degree temperature all around us in the room. Because remember, my ice cubes were only 36 degrees. So our conductor was causing our temperature to equalize. When you use the word heat, heat is the process of heating something up. Temperature is how quick the molecules are moving in the items and the air all around you. So, when we put the ice cubes on here, the conducting material sped up that process, causing those ice cubes to heat up and melt. Think about all the places where you see conductors and insulators in the real world. When I think about a wire, what do people make wire out of? This is made out of aluminum and copper. Don't they usually make wire out of copper? Don't they usually make the coating around the wire with something plastic, with an insulator? We usually don't choose to wear metal clothing. We usually choose to wear cotton and wool, and both of those are really good insulators. So be thinking during the week about why engineers chose to use plastic or rubber on some items, and why they chose to use copper or steel on some other items.